Howdy students, this is lesson 6-7. In this lesson we're going to learn how to classify polygons in the coordinate plane. Go ahead and do the vocab here and I'll check back with you. All right, here's just a concept summary of the formulas we're going to use here. We need to know the distance formula if we need to determine whether sides are congruent or diagonals are congruent. We need to use the midpoint formula if we need to determine the coordinates of the midpoint of a side or whether diagonals bisect each other. And we're going to use the slope formula if we want to know if opposite sides are parallel, diagonals are perpendicular, or sides are perpendicular. So go ahead and place a letter in each blank here on 5 through 7. Okay, so we're going to use some of those formulas here to help us classify this triangle. We want to know if it's scalene, which means no sides are congruent, isosceles, which means two sides are congruent, or equilateral, which means all sides are congruent. So we need to find the lengths RS, and we need to find ST and RT, and then just compare them and see if they're the same or not. So we're going to use the distance formula to do this. So for RS, we're going to do the square root of, let me write down the points, the coordinates of each of these points. All right, so to find RS, we are going to subtract the x coordinates, so like -4 minus 3, square them, and subtract the y coordinates, square those, and when we do that, we're going to get 49 plus 4, which is the square root of 53, and I think that's good enough for simplifying. We don't need to round it to a decimal or anything there. Okay, now we need to find ST. ST, that is the points 3, 3, and 1, -3, so we're going to do the x coordinates 3 minus 1 squared, plus the difference in the y coordinates 3 minus -3 squared, and that's equal to 4 plus 36, which is the square root of 40. So those two sides are not the same. And then RT, we're going to do the square root of -4 minus 1 squared plus 1 minus -3 squared. And when we simplify that, we get square root of 25 plus 16, which is the square root of 41. So we can see they're close in length, but not exactly the same. And so we have to say that this is definitely a scalene triangle. And that's because all the sides have different lengths. All right, you try that. All right, the next thing we're going to do is classify a parallelogram. So we want to know if it's a rhombus. To figure out if it's a rhombus, we already know it's a parallelogram, so we know opposite sides are congruent. That tells me this is we already know these sides are congruent. So if we have a parallelogram that has, we can tell it's a rhombus if we know that all 4 sides are congruent. So we would just have to check and see if, like say, AC is equal to BC. If that's true, then it would be a rhombus. Or we can check if the diagonals bisect opposite angles. That's pretty hard to do on a coordinate plane, though. The other thing we could do is check if if the diagonals are perpendicular. If the diagonals are perpendicular, then we also have a rhombus. And that's what I'm going to do because I think it's easiest to use slope. So let's find the slope of AB. And so I'm going to need to write down the coordinates of these. All right, so the slope of AB, we need to subtract the y coordinates on A and B, and that would be the 2 and the -4. And then we subtract the x-coordinates the same way, and that'd be 5 minus negative 3. And when I do that, I get 6 over 8, which simplifies to 3/4. All right, so now I'm going to check CD, the other diagonal, and see what that slope is. So I'm going to subtract the y-coordinates, and I get negative 5 minus 3. Then I'm going to subtract the x-coordinates. I get 4 minus negative 2. And that equals negative 8, 6, which is negative 4/3 when I simplify that. And if those are opposite reciprocals, and the way we can tell is by multiplying them. If we multiply these two together and we get negative 1, then they are opposite reciprocals. And so we have perpendicular diagonals, and we also have opposite sides are congruent, so we have a parallelogram with perpendicular diagonals, so this is a rhombus. So if a parallelogram, if you have a parallelogram and it has perpendicular diagonals, then it's a rhombus. Go ahead, you try that. All right, problem 3. What is the most precise classification of the quadrilateral formed by connecting midpoints of the sides of the isosceles trapezoid? So first of all, we're going to have to find those midpoints. So we're going to do a little work here, and I'll just place them on here. But we know we'll have to use the midpoint formula to do that. I'll plot them on here. I'm thinking this midpoint is about right there, right there. And now I just need the coordinates of those, so I'm going to use the midpoint formula to get those. And just as an example, let me write down the coordinates of all these points. So here are the points. So to get the midpoints, this midpoint right here, I'm going to have to do negative 4 plus negative 3 divided by 2 to get the x-coordinate. That's negative 7 divided by 2, which is negative 3.5. The x-coordinate, and then the y-coordinate would be 3 plus negative 2 divided by 2, which is 1/2, so 0.5. I'm going to go ahead and fill in the other midpoints. All right, now I'm going to connect those midpoints. That. All right. Now, what I want to do is see a couple things here. If we have a parallelogram, then from that we can go ahead and figure out if we have a square, rectangle, or rhombus. So the first thing I need to do is find the slopes. And there's 4 slopes. Let's label this A, B, C, and D. So we have slope AB, we have slope BC, slope CD, and slope AD. So slope AB, we're going to take negative 3.5. Oh, sorry. We're going to take 3, the y-coordinates, 3 minus 0.5, and divide that by the difference in the x-coordinates, which is 0 minus negative 3.5. It's a minus and negative there. And that's going to give me 2.5 over 3.5. And if I simplify that, I actually get 5/7. What I did is I multiplied both those by 10, and then I simplified that fraction. I'm going to just write down the rest of these so you can just see them. I'm not going to go through figuring those. So I got all my slopes, and I now can tell that this is a parallelogram. So at the very least, we can label this a parallelogram because opposite sides are parallel. And we knew that because we have the same slope. AB and CD have the same slope. Now, I'm going to check out my diagonals because then I can find out the rest of it. If my diagonals are perpendicular, then it's a rhombus. And we can already see that the diagonals are perpendicular because on a coordinate grid, every horizontal line is perpendicular to every vertical line. So ABCD is a rhombus because AC and BD are perpendicular. Now we could have a little more. We could actually have a square, and what we would need for this to be a square is for our diagonals to be congruent, because then we'd have a rhombus that's also a rectangle, and a rhombus that's a rectangle square. On a coordinate plane, you can get the distance just by subtracting the y-coordinate. So the length of BD is just equal to 3 minus -2, which is 5. And the length of AC is equal to 3.5 minus -3.5, which is 7. And so we don't have congruent diagonals. So the best that we can say is that this is a rhombus. Go ahead and try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll talk about that next time we meet in class.